All right, good morning, sixth grade. Today you're going to need a piece of graph paper. So I'd like you to get a piece of graph paper and draw a x-axis and a y-axis. And we're going to go ahead and label it from 1 to 10. And then we'll go down to -10 on the other side. So if you need to pause the video to get your materials, do that and then come back. Okay, so I'm going to continue. Now remember that the labeling happens on the end of the space, not in the space. So here is the origin where my pen is at 0, 0. 1 is the end of the first square, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. Now my numbers are on the lines because it's the end of the space where that value occurs. Now, in the opposite direction, we would go with the opposite integers. So if 1 is one space from 0 to the right, -1 is one space to the left from 0. And then -2, -3, -4, -5, -6, -7, -8, -9, and -10. So those are the coordinate values on the x-axis. Now on the y-axis, we would do it as if we were going to rotate our paper 90 degrees clockwise, and we would do the same thing. So this is the origin, 1, and I'm going to write it right on the x or the y-axis, I think. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10 on the lines themselves. The opposite direction would be -1, -2, -3, -4, -5, -6, -7, -8, -9, -10. Kind of hard to do the negatives on the line, but you get the idea. All right. So now today what we're going to do is we're going to plot some points. So I'm going to actually use a different color pen to do this. And then we're going to reflect those points within the coordinate plane. Now a reflection, you know, when you look in the mirror, you see yourself, right? That's a reflection. So we're going to look at what happens with reflections on the coordinate plane. So the first point I want you to plot on your coordinate plane is 3, -2. So we're going to start at the origin. 3 is the x value, so we're going to move over 3 spaces to the right because it's positive. And then the y value is -2, which means we're going to move in a downward direction. And I'm going to put a point there, and I'm actually going to label it 3, -2. Okay, now we're going to do something a little different. So I want you to pick up your piece of paper. So if you put this in your math notebook, you'll need to pull it out because you're going to need to fold this piece of paper. We're going to fold it along the x-axis. So be as precise as you can, and you'll have to kind of look through to the other side and see if you can't get that folded. Let's see how I did. Not too bad, not too bad. So hopefully your fold is right along that x-axis. Okay, so what we want to do now is we want to kind of look through the paper. So I'm going to fold the front half down, and I'm going to see my point that I put through the paper. So I can kind of see where it is. So I'm going to draw it again. But now it's just really tracing it from the other side. Now when I open the paper, I can see where that point is in quadrant 1. So I'm going to now draw it on this side of the paper. And I want to locate its, identify its location. So it is 1, 2, 3 spaces to the right and 2 spaces up. So we would label that as 3, 2. Now, what do you notice about those 2 points? Well, they have the same x value, right? What's different are the y values. The first one was a -2, so it was below the x-axis 2 spaces. And the second one was above the x-axis in 2 spaces. So that is called a reflection. So this second point, which I'll just call B, this was A. B is a reflection of point A over the x-axis. Okay? Now, what if we go back and reflected point A over the y-axis? Well, we could do the same thing. This time, though, we're going to fold over the y-axis. So again, do the best you can, flipping your paper over and try to fold it right along that y-axis. Not bad. So now, here's my point A. I'm going to fold this down and trace it on the back side of this paper. I can see where it is because I'm using pen. And then when I flip it back, I can draw that point right there. And let's name its location. So we start at the origin, we move horizontally first. We would go 1, 2, 3 direction, 3 points or spaces in the negative direction. So the x value is -3, the y value is -2. We'll call this point C. Now, what do you notice about point C? Point C relative to point A. Well, they have the same y value, but the x values are opposite of each other. And that is because we had a different direction horizontally, but we went down the same amount vertically. This point C is a reflection of point A over the y-axis. Now, what if we did this again? What if we reflected point C over the x-axis? So fold your paper down on the x-axis. Find point C. That one's a little harder to see for some reason. There it is. So I'm going to draw, this is point D now. And what can you say about point D? Well, where is it located? We start at the origin. We would count 3 negatives for the x value and then 2 positives for the y value. So it would be -3, +2. And again, if you compare C and D, they have the same x value because you moved in the same horizontal direction, but we moved in opposite vertical directions. So C had a negative y coordinate and D had a positive y coordinate. Okay, hopefully that makes some sense.